Okay, so I'm recording this video because we were having massive technology issues. I'm going to upload this to YouTube. Okay, so here we are, we're talking about friction right now. Friction is a force that opposes motion. So in this example, we have a block. I'm trying to move it with a force to the right, and friction is going to try to oppose that force, and it's going to push to the left. The force of gravity on our free body diagram is acting down. I'm just using Fg to signify the force of gravity. The normal force is the force that is pushing up. That is the same as the ground force from what we talked about the other day. We're only renaming that the normal force. In more advanced physics classes, this normal force is very, very critical. It has to always be perpendicular to the surface of contact. You do not need to worry about that for the purposes of this class. So we're going to try to apply a force to the right, and friction is going to try to oppose that motion by applying a force to the left. We have two types of friction that we're worried about. The first is static friction, and then the other is kinetic friction. Static friction is the friction before the object starts to move. So if you've ever moved a heavy object, you know that you need to apply enough force to get that object to start moving. Down here, I'm right now pushing against the red marker, and in order to get that marker to move, I need to overcome the static friction. Kinetic friction is the friction while the object moves. Okay? So two types of friction. Static friction before the object begins to move, kinetic friction while the object is moving. We're going to use the static friction to check and see if the object is going to move. And then once we confirm that the object moves, we completely ignore the static friction. The static friction is only a check as to whether or not the object will move. We then move to kinetic friction, and the kinetic friction will be applied the entire time that we apply this force. In order to calculate the friction, we need something called the coefficient of friction. This right here is the Greek letter mu, not Pokemon 151. It is the Greek letter mu. It looks like a cursive U if you're having a hard time drawing it. This is known as my coefficient of friction. This is known as the coefficient of friction. Every surface has a different coefficient of friction, and you guys know this. Carpet has a higher coefficient of friction than ice. That is because it is harder to move something on carpet than it is on ice. So different surfaces will have different coefficients of friction. Okay? So how do we apply all this to a problem? Well, we use the coefficient of friction and the normal force to calculate the friction. So if I want to calculate the friction, I multiply the coefficient of friction, mu, by the normal force. This is how we calculate the friction force. We multiply the coefficient of friction by the normal force to calculate our friction force. Okay? Let's put it all to use and do a simple problem. Okay? Once we do a simple problem, this gets much, much easier. Okay? We're going to use the same approach in every single problem. Here we have a 5 kilogram mass. We're applying a force of 20 newtons. And I have a coefficient of static friction equal to 0.3 and a coefficient of kinetic friction equal to 0.1. We want to find the net force acting on this object. We're going to start with a free body diagram. So we have the force of gravity acting down. We have the normal force acting up. So I don't have to write normal over and over again. We're just going to write Fn for force normal. I apply the 20 newtons to the right, and then we have the force of friction. And so I don't have to write friction over and over again. We're going to write F for force, and then Fr for friction. Okay? So that's my free body diagram. The next step is to figure out how much gravity force we have acting on the 5 kilogram mass. We remind ourselves that we can always find the force of gravity by multiplying the mass times the acceleration due to gravity. So this is ma. The mass is 5 kilograms. We're multiplying by 10 meters per second squared. And so I get 50 newtons of gravity force. That means that the normal force is also equal to 50 newtons. Remember, this box has to be balanced along the y-axis. It's not falling through the floor and it's not levitating, so it has to be balanced. So 50 newtons down of gravity force, 50 newtons up of normal force, okay? We're going to use the normal force to calculate our static and kinetic friction. So the force of friction static is going to be equal to mu s for static friction coefficient multiplied by the normal force. Our static friction coefficient is 0.3. We multiply by the normal force, which is 50, and we get 15 newtons of static friction. We now compare the static friction to the force applied. I'm applying a force of 20 newtons. The static friction is 15 newtons. So I push with 20, the static friction is 15. This means that the object moves. I am applying enough force to get the object to move and overcome static friction. Once you confirm that you overcome static friction, you completely ignore the static friction. It's not used anymore. It is simply a check to make sure that the object moves. We then move on to kinetic friction, which is going to be mu k times Fn. Our mu k is 0.1. We multiply by 50, and I get 5 newtons of kinetic friction. 5 newtons of kinetic friction. So now I have 20 newtons trying to push us to the right. I have 5 newtons trying to push us to the left. So the net force is 20 minus 5, which is 15 newtons. Okay? So the net force is 15 newtons in this case. 15 newtons in this case. We start with a free body diagram to figure out what the force of gravity and normal force are. In this case, the force of gravity is always found by multiplying the mass by the acceleration of gravity, 10 meters per second squared. We use that to find the normal force. The normal force was 50 newtons. Static friction is calculated using the static friction constant and the normal force. We got 15 newtons. We confirm that the object moves, and then after we confirm that the object moves, we ignore the static friction. We focus on the kinetic friction, which is 5 newtons, that's 0.1 times 50, and our net force is equal to the difference between the applied force and frictional force, that's 20 minus 5 is equal to 15, okay? The great thing about this video is you can pause it and write all this down. Let's now move over to the other whiteboard where I have some example problems, okay? So we're now going to work on these example problems. And again, the best way to go about doing this is I'll describe the sample problem. You can pause the video and try to get the answer on your own. Here we have a 10 kilogram mass. I know it's a little hard to see. 10 kilogram mass, 40 newtons of applied force. Mu s, the static friction constant, is 0.2. Mu k is 0.1. And we want to find the net force acting on this object. So very similar to the previous problem, only the numbers have changed. If we were in class right now, I would ask you to try this problem, but then we will go through it. You should pause this video and try to get the answer on your own. Dramatic pause. Okay, I'm going to go ahead and solve this now. You should have already tried this on your own. First thing, free body diagram. Force of gravity down. 10 multiplied by 10 makes 100 newtons of gravity force. The normal force is equal and opposite. That's also equal to 100 newtons. We're applying 40 newtons, and the force of friction is opposing the motion. We calculate the static friction and the kinetic friction. Static friction is mu s multiplied by the normal force. Mu s is 0.2 multiplied by 100. So we get 20 newtons of static friction. 20 newtons of static friction, we're applying a force of 40 newtons. That confirms that the object moves. That confirms that the object moves. We've confirmed the object moves. We now completely ignore the static friction. It's not necessary anymore. Move on to kinetic friction. Force of friction kinetic is equal to mu k times the normal force. Our mu k is 0.1 times 100. We get a kinetic friction of 20 newtons. So I'm applying 40 newtons. I've got 10 newtons of kinetic friction. So the net force is equal to 40 minus 10, which is equal to 30 newtons. Okay? Nice and straightforward, not too difficult. Next problem. 20 kilogram mass, we're applying a force of 50 newtons. Mu s is 0.3, mu k is 0.1, and we want to find the net force on this object. So again, same thing, only the numbers have changed. Once again, you should pause the video and try this problem on your own. This gives me a chance to sip a little bit of coffee. Dramatic pause. Okie dokie. First thing, free body diagram. Always, always, always. Always start with the force of gravity. 20 multiplied by 10, which makes 200 newtons. That means the normal force is 200 newtons. We're applying a force of 50 newtons. Friction is going to oppose that. Okay? We're going to calculate the static friction using the static friction constant. So we've got 0.3 multiplied by 200, and that's 60 newtons. So we have 60 newtons of static friction, but we're only applying 50 newtons of force. That means the object does not move. The object can't move because we have not applied enough force to overcome the static friction. We have not applied enough force to overcome the static friction. That means the net force is 0. The object will not move. Now be careful. I'm applying 50 newtons. The static friction is like a limit that I have to overcome. Nobody has ever tried to move an object and then the object goes shooting in the opposite direction. So the 50 newtons of applied force is canceled out and the object will not move. Okay? Next problem, a little bit more complicated. 10 kilogram mass, and then on top of it is a 5 kilogram mass. 10 kilogram mass, 5 kilogram mass on top of it. We're going to assume that the 5 kilogram mass and 10 kilogram mass are going to stay stuck together. Mu s is 0.4, mu k is 0.2. We're going to apply a force of 90 newtons, and we want to find the acceleration on this object. Okay? I'm going to dramatic pause on this one so you can try the problem on your own. Dramatic pause, dramatic pause, dramatic pause. Okay. The hardest part on this problem is figuring out what is the force of gravity. Since there's an object on top of another object, we have to add together all that mass because all of that is pushing down on the floor. So it's not 10, it's 15 times 10, which makes 150 newtons. So the normal force is 150 newtons. Let's be careful there. We don't just worry about the 10 kilogram mass, we have to worry about the 5 kilogram mass on top. We apply 90 newtons of force, and then we have the force of friction right here. With all this information, the last thing you're going to have to do on this problem is use F net is equal to ma. So you're going to find the net force the same way we have in the previous few examples, but then you're going to use the mass and the acceleration to figure out the overall acceleration. You're going to use the net force and the mass to find acceleration, and you should get an acceleration of 4 meters per second squared. I'm going to leave this one open-ended, and I expect you guys to use the discussion board if you have any questions on this problem, and if you post how you got the answer on that discussion board, this also gives you a chance to earn some class participation points.